Is it not recording, Kyle?
Yes, it's recording.
Yeah, I think you're good.
Everybody has probably to accept.
Can you guys hear me?
We got you, Sergio.
Cool, perfect. Hey man, how's it going?
Good, how are you?
Good, good. Fighting with my computer, but now it's working.
Nice.
Bueno, thank you everybody for being here. It's a pleasure to be in this, at this point that is not the last, but is one of the most important of the master thesis, the oral defense, the public oral defense. It should be 1 hour, or patient is a little bit shorter, because the public event should be 1 hour with the questions and everything, okay? But shorter as the noise, you guys will have opportunities to ask questions. A close meeting with the committee as long as needed until we decide if we pass or not, or pass with revisions. That is the common thing, pass with revisions. We have today the committee or Herdhanu Jayanto, who has been one of the most important students in the forestry department. He has been a graduate student, came from Indonesia with his research in crocodiles, thanks to Dr. Shaney, that is here in the corner. Many of you remember him, a professor at Highlands that led us to work in Texas A and M University in Kingsville. Thank you, Kyle. He's a wildlife specialist and is the main mentor of Herdhanu, who has been still working with him all these years, and they will probably work in the future together too. Then we have in his committee Sergio Balaguera-Reina, who is also a wildlife specialist from the University of Florida. He's also a quantitative ecology specialist and has supported Herdhanu in his trajectory. Thank you for being part of this committee.
My pleasure.
The third person very important in this committee is Dr. Tsatsaros, faculty water specialist in our program, who has experience also in that part of the Caribbean and Indonesian area of the world, and a specialist in water science and coral reefs, amongst other things. And then the last, but I hope no less, because I serve as his mentor at Highlands, is me, Blanca Cespedes, chair of the forestry department for my last semester and year. I'm very grateful to have had Herdhanu in my life, because I grow as a professional being, as a human being. So with that, and before crying, I think it's important to leave Kyle to say something if you want. Kyle, as a main mentor of Herdhanu, I'm really grateful that you are here with us today. Please feel free to share with your former students.
Thanks, Blanca. Yeah, it's great to see everybody. Hi to all my friends at Highlands. It's good to see everyone. Yeah, so just to add on to that, I really appreciate everyone on the committee and all the time everyone's put into this. And I want to just say how proud I am of Herdhanu. He's put a lot of work into this. He took on a project that I can't really explain how logistically challenging it was. As you'll see in the presentation, some of the things he went out and did in the field were very difficult to do. They hadn't been really done before. He worked on one of the least studied crocodilians in the world for his thesis project. I think a lot of what he did was something that you would see more on a PhD level thesis. So I'm very excited to see his presentation today, and I'll let him take it away.
Thank you so much, Kyle. And I also forgot to say thank you to a person that is important for Herdhanu, specialist in crocodiles too, Dr. Amir, that works in the National Research and Innovation Agency and deserves recognition. I'm sure Herdhanu is going to make it more explicit, but just in case, that person is part of this science. Okay? So now put the view of locale. I'll change the view. Please. Check. 2:34. This presentation, the public event, will be finished at 3:35.
So, okay, it's working. Okay, good afternoon, everyone. Thank you for being here and welcome to my thesis role defense for the my thesis entitled Movement Ecology of the Sunda gharials in Berbak-Sembilang National Park in Jambi, Indonesia. So thank you for people here, all nice, and then I see a lot of my acquaintance in the Zoom. Thank you for joining, especially for people from Indonesia. That is now early morning, 3:30 a.m.
What did I say, morning?
Thank you so much for waking up to see this crocodile. So, my name is Herdhanu Jayanto. People know me as Danu. I'm a master's student in the natural science major, Department of Forestry in New Mexico Highlands University. And my super committees here, all, including so I have 5, and the other is one from Indonesia, Dr. Amir Hamidy, who also opening the path for this research for me, Dr. Chow. So thank you. So without further ado, let's dig in. So I can start with the 3 key words here in my research, which is movement, and the main celebrity here, at least during this session, which is the Sunda gharial or Tomistoma schlegelii. It also known as a Sunda gharial or false gharial in English, and in bahasa Indonesia, Sinulong, Buaya Satu, Buaya Sumpit. All refer to its morphology, body shape, its uniqueness that has a chopstick-like snout. And in the world, among the 28 crocodiles in the world, there's only 2 crocodiles that really have slender snout, which is the other one is the Indian gharial that also found in Nepal and Pakistan, 2 of my friends here. Oh, and Professor Ram as well. So it's like a distant brother or sister of that species, and the size of this big guy can reach more than 5 meters. Quite big and described by Mueller. So here's the historical drawing of this crocodile, and it's distributed in the Malaysia and Brunei Darussalam, and also of course Indonesia. In Indonesia, we can find it in 3 islands here, in Borneo Islands, known as Kalimantan in Lombok, and Sumatra, and also in Java. I live here, by the way. And we're gonna focus on this area with the green color, which is the Berbak-Sembilang National Park, and we will know why. But next, I want to introduce you to this site, the Berbak-Sembilang National Park. Here, it's quite big national park, consists of the more than 300,000 hectares. And was separate 2 national park, and then we combined in 2016 due to management reason. And this one is the Berbak section, and this one is the Sembilang section. So we're gonna focus on this Berbak section, which consists of the 160 to 700 hectares, and 60% of them are heathland forest. And as you can see, it's, the position already. Now get into more context on this national park condition. There was a wildfire, historical wildfire since 19 97, and next one is 2015, and then 2007. So you can see there's patches here due to the wildfire, and it's all surrounded by the concession plantation, usually the oil palm plantation. So there's a lot of pressure on this national park. And this is the maps of the Blanca park. You can see this is the plantation, right? Also these patches of the wildfire again. And this is what the habitats looks like in the Berbak section. This is the post-fire impacted area. This is the, you can say, pristine area here. It's one forest here. And this is the, like a transition between the post-impacted fire and the pristine habitat. And why we study this? Tomistoma. So we're gonna call him Tomistoma for now, just easier. It's a unique species, evolutionary distinct, and has some paper has some metrics to see the distance of these crocodiles among the crocodiles in the world, and included in the list of the so-called H species by the Zoological Society of London, that is the evolutionary distinct and globally endangered species. And it's also protected species, of course, and have a global attention. It even has a World Tomistoma Day on August 5. I don't know why, but it's good for its species. And of course, generally for the shared goal of collective goal, SDGs, and then current global biodiversity framework. It's a good thing to study this species for its conservation. And then next is the profile of the Berbak-Sembilang National Park. It's a national strategic area, and it also listed as Ramsar site, wetland convention, international convention, and then UNESCO biosphere reserve, and then important site for the bird. Some ecosystem services provided by the Berbak National Park is the including recreation, biodiversity safeguard, and then food and economy. This is the tapak fish, which can grow up to 1.5 meters. And also the carbon sink, while there's of course there's a threat to this national park, which is wildfire, and then illegal hunting and poaching for the wildlife there, and then land use change and waste and habitat degradation. So to connect the dots, important species and important sites belongs together. It's some kind of like a priorities to the conservation, of course. And since we know from Dr. Kyle project back in 2015, when he was on the National Geographic Explorer project, we know that the Berbak-Sembilang National Park is the last stronghold for the Tomistoma population in Sumatra Island. So what we're studying? So we have 4 questions related to the movement of these species, and I'm going to explain why we're choosing these topics. First is the home ranges of these species, like how big is the home ranges of the Tomistoma, and then second, is there any ocean travel for these species? And the third one is the, I'm gonna put this water away. Good, it's better. So the third one is the connectivity. Is there any connectivity among the, especially the tributaries here? And then is there any specific movement pattern to inform the management plans? As we know from the remote sensing here from the maps, we can only see the water bodies, but we don't know if it's the challenge for the remote sensing that we cannot penetrate the canopy, so we don't know if it's a dry forest or it's a flooded forest in here. So we don't know if there's any water for connectivity, especially in context of the Tomistoma corridors. And then, especially, there's one important thing I want to note that in this Berbak-Sembilang National Park, there's 2 species of the crocodiles. The other one is the saltwater crocodile, the reciprocate, the most largest reptiles in the world. So from the crocodile research, we know there's like a niche partitioning here. The saltwater crocodile tends to occupy the coastal sites, while the Tomistoma tend to occupy the midstream and upstream river.
Okay, it's working now. Thank you.
So why movement ecology? It's we can say it's a good tools for the conservation and management. Not really silver bullets for everything, but it has a utilization like here wildlife corridors here that would be important. I'm gonna demonstrate the example after this. The benefits studying the movement ecology and understanding it is to use it in the landscape and human wildlife management policy, and then the conservation policy making, development and climate crisis mitigation, and also it's my own personal interest. And in context of these species, it's a novel study because it's going to be the first movement ecology study for this. For not for the species, but for the adult species of this crocodile, because there was another movement ecology study, but limited to the juvenile individuals in the World Movement. So this is the formal context for to get familiar with the movement ecology. We're gonna off the course a little bit to the Africa. Here are the example from the elephants corridors. You know, there's a wildlife, human wildlife complex in the elephants. Like elephants came to the human settlements and then propagating everything and including house, and they have tremendous power to damage everything. It's we know that the elephant has their historical track. So these elephants life, the NGO use the movement ecology data to identify the corridors of the elephants, and then can predict where they move, and if it's intersecting with the villages. They have the elephants response unit, and they're using the beehive fence to make the elephants go away and then keep people safe. And the beehive is useful for their income as well for the people like people. That's another example. Another relevant examples such as the zoonotic disease COVID. It's related to the movement ecology of the viruses, and there's many things that related to the movement ecology, including like the companies such as Uber that use the spatial movement to see the demands on the certain areas. So it's the implication of the. So we're moving to the methods, how we do it. So this is our side. We're focusing on the air hitam laut river basin. This is if I can translate it to the English, air hitam laut is literally black water. So it's a black water. It's of the big swamp forest influence. And each this is the river basin here, and each has their own local names, but to differ the sections here. And how we do it, we go there, of course, and then we capture the crocodiles using the traditional trap. Thank you for our local champion that have the ideas to modify the traditional Dayak traps, and then we capture, and then we put GPS tags on it, and then we can get the data, and then after that the data will be analyzed generally overall using R and RTLS. And also some of the data came from the BMKG's. It's the Meteorological and Climatology Agency from Indonesia. And this is the crocodile that we caught. We use we explored 3 protocols for the attachment using the epoxy and then the steel wire and also the nylon wire on their dorsal is around here, and then the tail here. And all the methods are approved, and it's harmless to the crocodile and also the handlers. For me, I still have my fingers. Except that you accidentally glue on your crocodiles like this Agatha here. He went to the boarding for the Tomistoma research as well. So we caught 5 crocodiles. We gave them a name, obviously. And here's the name. Quite difficult to spell, but we have Bujang, Mentek, Jaki, and Jonbro. But fear not, just remember the 3 names of Mentek, Daus, and Jaki. The reason why I will say to you later. So, and then we're gonna estimate the home ranges of the crocodiles in the data. The data includes the GPS coordinates, time and date, and also the other data, but these 3 are the most important things for our analysis. And we use 3 home range estimator that are well known. First, the minimum complex polygon. It's really straightforward. We use the outermost points and then connect their dots, and we get the size of the home range. And then the other 2 is the kernel density and then the kernel adaptive local complex rule, both using the kernel function, that is the probability density function here. Don't be intimidated, everything. It's just the illustration here. We use the, in kernel density, we use the smoothing factor here, usually to get different crust. And here in our study, we use the a priori value, which is the 100 meters. And to illustrate the kernel density, we'll produce the heat map like, so like a hotspot, like a fire hotspot in the forestry. So you can see which places utilize most by the Tomistoma. And same with the adaptive local complex. The difference is instead of only using the radius of the smoothing factor, it's use the K neighborhood likelihood. So combined. And here another data we converted into so we got the GPS coordinates. Once we got the GPS coordinates on the sequential date and time, we can calculate the movement travel distance here, like this, connecting the dots from the GPS fixes. And then we also have time data, so we can calculate the movement speed using this simple function. And then we're gonna do this descriptive statistic or comparison of all these 5 crocodiles, also by grouping the season and the day-night activities. And then next, we're trying to understand what factors predicts the movement speed of our crocodiles. So we use the models, generalized similar model. We run the diagnostic before to see if the assumption fits, and in the end, we use the generalized GLM and the package we use. We use the AIC for the model selection. And then we use the covariates factor that we want to test. So we have 3 categorical covariates, which is season, dry and wet, day or night activities. And then the habitat type, we use the land cover from the Sentinel-2 that processed by the S3 and impact observatory. It's a 10-meter resolutions. And then for the continuous variable, we use the spectral indices, with 2 of them, the modified Beresford index and then modified normalized difference water index. So, and then another covariates, we use the moon phases, rainfall, and then sunshine duration. We got from the climatology agency. And here are the results. So this is the data that we got from the our crocodiles, 5 crocodiles here, and here is the home range based on the MCP. So from the GPS point, we connect the ozone layer, and then we get this number. Oh, I forgot to mention that we use the 95% far field and then the 50% far field to see the utilization distribution for crocodiles. So basically in the home range analysis in wet lab, 50% can show the dense spatial resolution that can tell if the species really use that area a lot compared to the 55%. So we got this number. Mentek is the biggest one. Mentek is here, the one in purple, and the other Gauss is the blue one, and Jackie is the orange one, which is while Bujang and Jogo, they only gave really a few points less than 15. So I can say that for now we can just ignore them because they're not giving meaningful information. And then the other estimator using the local context file, we got this estimation is the most smallest estimation compared to the other two here. And Mentek still consistently being having the largest estimation for the coverage. And then this one is the kernel density. You can see the difference here of the shape. If you compare on the MCP, you get the heat 50% for area here, you see the 50% KD. So this is the place that Mentek use a lot. And then the outer layer is the 25%, and it's making a shape. You can see if there's a connection here, or it's a quite stretch compared to the other bells and jackets, more delineated, and we're gonna talk about it shortly. And this is the estimation, the number of the ranges. Again, like it's the biggest, and then those and Jackie, and then followed by those. Same order in the 50% areas. And here's the movement with our crocodiles. You can see. So again, it's a 30-second view. So you can see what's you can like easily observe what's the difference between these two. This Mentek crossing intersect these trees that we don't know if it's one forest or not on the satellite imagery, but if ground truthing, we know that this is at least from the basin of the river is salt water. So there's we found the connectivity here from the based on the imagery maps that we can say this is the each one forest that provide the water access to the Mentek. And compared to that, the Jackie and Bujang movement is really streamlined to the river, and we can say it's probably affected by the impacts of the wildfire. But now remember that we have 4 questions. The second one is the ocean travel. Since our most closer is points to the ocean is like 29 kilometers away, so it's still mysterious if they're doing the ocean travel. Then connectivity, I have mentioned that here. So if you can see the river is from the satellite imagery, there's another branches of the river. So there's Mentek actually doing this movement, connecting from this river to this river using the fixed one force axis. And then the fourth one, you're moving characteristic from the ship and we go deep into deeper this. And we have a question on behaviors on the crocodile, or our data can't explain it, but theoretically, this YY Mentek behave like why Mentek navigating to these north instead of the Gales. So we may explain this by the optimal foraging game theory. So the difference here and here is the prey availability based on our observation and then the anecdotal information from the fishermen there. The fish, for obvious reason, is more abundant here, and fishes like Papa, the big one that more abundant, easily can be found here, and that's our food there. So while we're there, and then there's also trees that provide habitats for small mammals such as macaque, monkeys, squirrel, and the other. In the optimal foraging game theory, explained that if there's a option of prey like fish and, in this case, fish and macaque, the one that has a good profit, which is have a good ratio of cost benefits, and the other is the prey that have larger body, but it don't necessarily have more profit. The animals tends to choose the second one, which is the largest. So this may explain why Mentek go there to find more prey rather than go to which one the fish. And also there's a side fidelity in crocodiles. They tend to get back to their home. So based on the anecdotal information from our champion, which is spent 20 years observation of these Tomistoma, he said that this site is the breeding site of the breeding and nesting site of the Tomistoma. So probably there's a probability that Mentek navigate to this place not only by because of prey, but also to have a partner there. Maybe I hope so. And then okay, this is the we're gonna focus on the gharials and Jambi, the place the area impacted by fire. Here, as you can see, here is the time lapse of from 2015 to 2020. You can see this area has been historically impacted by fire from 2019. And our second follow-up question is why gharials and Jambi don't move to Mentek place where there's a more food abundance. So we don't know from our data, but we may explain why it's probably because the combination of the site fidelity and then price switching. You know, while Dr. Kyle did his project here, it's before the fire, so it's all. We got the good record of the habitat condition in this area, which is similar to the habitat to Mentek. So all trees and then probably macaques there and tiger as well, but it's not the threat of the Tomistoma. So they might adjust by price switching because crocodile is quite resilient, and there's also a combination of the territory partitioning. When we call Jambi and gharials, there's a sign of the injury from the fighting over the crocodiles for the territory. And our crocodile were males, so they tend to have a territory. So that's why they won't cross the. For now, our data suggests that they will cross the place. And the post-fire impact now limit gharials and Jambi movement, what suggested by the shape of their convention movement. So compared to the Mentek, while he can cross the forest, gharials and Jambi is having a difficulty. There's no movement, at least from our data to forest, because it's all bushes, grasses, and then the fallen logs, which is make big crocodiles having a difficulty to cross that area. And then there's a probability of the shrinking area of occupancy. Since we know that in the coast we have a saltwater crocodile, And on the outside of the this national park is all vegetation. Basically a degraded habitat. So they pressure from the downstream and upstream, and then there's a risk of the area of occupancy shrinking. And next is this is the data from our GPS points. That there's a critics on our data as well that we might be biased through the dry versus wet season and important versus chemical position based on the transmission ability for the GPS tag, because it's not working when it's underwater. So we really rely on their behavior when they surfacing. So you can see that most of the data from Laos and Jackie provided from the dry season here, while the Mantek on wet season. And if you see the habitat type, it's of course representing the post-fire impacted, which is more of an area without canopy, and then Mantek with canopies. So when crocodiles usually tend to avoid humans' attention, especially these species that really shy. So usually when wet, they're gonna submerge more. And while dry, where the water level is insufficient for them to submerge, they're going to expose in the open area. That's where you can transmit the data. While Mantek in dry, it's difficult for him to access. So opposite to the same thing. There's a pattern here. And also moving on to the movement speed. Just want to demonstrate that we have the data that asymmetrically and consistent throughout the years. There's a quite a gap there between the individuals, so that's the limitation of the data. And then this is the comparison of the movement speed. This is comparison by the individuals. So the movement speed, we have the value of maximum is 900, more than 900. While the Jackie, the one in the post-fire impacted area, has the highest mean. And next is Mantek. So Jackie has the higher means than Mantek. So we cannot suggest anything, but there's a difference between every. And then grouping by the season and day night. We have the same maximum, which in dry season is provided by Jackie. And it consistently dry movement in dry season have highest mean compared to the movement during that. But again, our data limitation is really highly rely on the data transmission or GPS. Okay, so we try to get the explanation of their what factors influence the movement, and we run the GLM, the model selection. So this is our 3 top models using the NMC, and we got the covariance of the rainfall, MBI, and the interaction between season and moon phases. And then the summary of the models suggests that the MBI and moon phase and season interaction season between and moon phases contribute significantly to the movement speed. However, our R is really low, so barely 1.5%. So that's really low predictive ability for our models. But if we can explain why these 3 is the most significant predicting the movement speed, it's the MBI is related to the habitat quality. So MBI is special in this is that can make giving quantified way to distinguish between bare soil, vegetation, and water, while the highest index, which is 1, is the bare soil, and the lower is representing the vegetation and water. It provides a quantified way of the And moon phases, it's being consensus, particularly in the Indonesian herpetologists, that usually we have low encounter rate of the reptiles and amphibians during the year. So don't go for the herpetological surveys and improvement in Indonesia at least, because they tend to hiding. That's the consensus. It's also supported by the empirical information from the frog hunters. But how about the evidence from scientific? There's a mixed response. Some species tend to show up on the other species in amphibians tend to hiding in their supplement, but at least in crocodile, most of the crocodiles, they tend to hide. These two examples from the American alligator and the Simon's crocodile in Kalimantan. And this is our diagnostic of our model. Okay, this is the good part. So what's the conservation and management implication? How do we make our result beneficial or meaningful? So we use we adapted the One Health approach and then the adaptive conservation standard. We have 5 steps of cycle: plan, implement, analyze, adapt, share, assess. So how we contribute to the vision of the Sunda National Park 28 and the conservation of the Tomistoma. So here are our recommendations. Not concluded yet, but we suggest to do the long-term study of the Tomistoma population and also the movement study, and then do the water level monitoring because currently there's no water level monitoring in the area, even though there's a regulating program. They have good monitoring. They have a good station for the real-time monitoring on the other side, but not this one. And it's also expensive and it access the internet. So we suggest do the water level monitoring using the simple poles and then set up a camera traps and then take time lapse every twice a day. So it is sufficient for the water level and then can capture the temperature and also the weather as well. And it's also for and then from the monitoring, we can know the population status because we're suggesting the ideas again later that I will show you. And since our study suggests there's a potential risk of AOO, area of occupancy, so it's quite important for the context of the things while noting this place is the stronghold in the Sumatra. There's a 3 prioritization place in the Badan National Park, and we provide the SWOT analysis, strength, weakness, opportunity, and threat. And then for the movement study, can make us understand about the sourcing dynamics and help to identify the region on the Berbak-Sembilang National Park level and also for the another population globally. So our study suggested that there's a connectivity potential in the Highlands forest. And knowing this, we can contribute to the potential of the conflicts, because even though these shy species compared to the saltwater crocodile, there's evidence that the attack of the Tomistoma is rising throughout the times. So since they're pressured from both sides and there's also possibility that they're gonna migrate to the human settlements or more often. And then all of them, we propose the idea of Tomistoma as a surrogate species, representing the freshwater communities in the peat swamp forest. It's not tested, so we hope in the future we can test that. And also this is the current program in Berbak-Sembilang National Park. There's other ecological study invited that we can have the understanding for the species of the international conservation and also that would benefits to the community, aquatic communities in the peat swamp forest process. And then water level monitoring contribute to the impact measurement from the current program, the national and the national program and the national park program we went in, and then we planted. That's why the opportunity to have collaboration with different clients. And but for now, it's more tend to be a fire prevention program rather than the restoration. So there's a lot of room to improve. And then our study also contributes to the, since we show the evidence of the minimum spatial requirement of the Tomistoma 400 hectares, and it's a protected species in Indonesia. So if the consensus, the plantation have there's the evidence of presence of Tomistoma, it needs to comply on the conservation value area constraints. So you need to provide the habitat for the species, for the protected species, which is require 400 hectares to corridors of or the habitat connectivity. That's how our study contributes. And again, for social responsibility, environment contributes to that. There's a partnership between the park as well, so they're not really, they're kind of really open for that, and it benefits for them because the European has been criticized, and the embargo of the products, especially oil palm products that don't have a good responsibility on the forest, so it will eventually will help their product as well. So yeah, that's our recommendation for addressing the simple and affordable activities that integrated to their future can have a huge impact. So for the review, we're getting at the end of the presentation here. So we estimate the orange sizes based on real estimators. The ocean travel has not yet been revealed. And we found the evidence of the special utilization for these shapes, and theoretically explain why. And we provide the evidence of the connectivity through the its own forest, and then we calculated the movement range speed compared to the other crocodiles, like saltwater that can swim 120 kilometers from coast to the upstream, the ratio potential to the species. And then we shown the factors that may affect the crocodile's movement, even though based on the very low predictive models. And then we provide the recommendation for the sufficient. That's it. Before we end it, I would like to thank you, my families, mom, dad, Puni, my beloved wife, and my cute little boy, Azza. And also super. Oh yeah, this is how we release them.
Everybody catching crocodiles.
That's the fun part. And this is the food. And then one of them are tapa, and I just checked in the IUCN website. It's endangered species. Forgive us. That's how we survive there. So thank you, friends, professors, and also our supporters. Thank you so much for your support. It's been very precious for me to be in this moment. I'm not gonna cry. So let's go. So this is the side reference, and then question, comments, feedback, job offer.
Thank you, Danu. And we have 15 minutes or a little bit more for questions. And take a look in the chat because there are questions. Okay, the presentation, great, Danu. Congratulations. There are no questions. Yes. A question here, Danu.
Yes, please. Yes, ma'am.
Yeah, fantastic. Good thanks. Thanks for the work.
Thank you.
Do you have any guesses why only males showed up in the traps and that you didn't mention females?
Yeah, we don't have the. That's a very good question, but it's very unfortunate we can get the female, but we don't have the evidence. But let's see, our guess is that because we went to on summer, that's the usual time that the Tomistoma just finished their nest guarding, so the hatchling just hatch, and that usually the females tend to just have a sight fidelity on the around the nest, so they don't move around much at all the podcast. It's when male have more probability to get caught, well, maybe they just don't as smart as not that smart as female. And then after that, the bird.
Yeah, talking about that question, do you think that females might have slightly larger home ranges than males? Because the bigger my species of turtles, usually females have way larger home ranges because they look for nests, necessary eggs.
Yeah. That's very critical. Yeah. For Tomistoma, we don't know because there's no data yet. It's the first study. But for the other crocodiles, like the saltwater miles and then some of the caimans, there was a home ranges studies, and there's the data from the female home ranges, and they tend to have smaller home ranges and like a predictable over the years because they tend to have the breeding side where they try to attract the males, and then the nesting sites. They usually use the same nest position over the years, except there's a disturbance like predators which means they that's in the case they will change the position.
Great job down here. That was awesome to see. Defense, you did a really wonderful job. I don't know if I have a job offer. I do have a question. So you built these great statistical models and ended up with these very, very small R-squared variables. So what variables do you think are explaining the variability in the data that you observed, and would you include in the model if you had to do it again?
Let's do it again. So originally we have like 9 continuous covariates, and then we draw 3 or 4 of them after the correlation tests. We use the temperature and then pull stuff, and then it's correlated together. If we do it again, we definitely will use the same covariates, but now we would love to improve the water level. So even though there's a lot of compounding effects on the water level, but it can expand directly to the axis where we try that's the best one. And we don't see anything wrong with the covariates. What we see is probably we need to improve our models instead of using the GLM. Oh, I forgot to mention that we use the gamma with the gamma family with the modeling function, and it's I think if we could improve our models, we would want to use the polylines models such as GAM, or maybe if we have a good amount of data, we can use the neural network with this, like really rough ideas. I hope it's
I'm going to jump just for follow
yes.
with him. Wonderful presentation, original and creative.
Thank you.
But so, what would be good number? You got 5 individuals.
Yes.
What would be your dream? If that's the limitation of the models, how many individuals would you attempt, or for how long?
Yeah. Good question.
Share with us.
Yes,
Please.
of course. So in the ideal world gold standard for the movement ecology data, for example, in our tag, we set the settings of we wanted it to send data every 2 hours, and then that's if we calculate, and if it's consistently giving us data, it will give us 3,000 data per year. So it's like a range number, 1,000 to 300 would explain a lot with their ecology. But here we have 150, 130 something each individuals. It can be enough, But it will be helpful if it's consistent. So this is also our lesson learned for the GPS, selecting the GPS model that have dry and wet phase sensor and also better transmission. And yeah, usually the GPS lasts 3 years. So if it works well, the ideal data consistent on every month basis and every month. Don't need to be very huge amounts of big data. The 550,000 would give us good understanding on their current.
I'm seeing James in the. So Julie, if you don't mind.
Yeah, I saw them too.
James, we
yeah.
see you.
Just real quickly, I just had a quick question about your covariates. You did you have distance to water as one of those at all
Yes.
time?
Yes, sir. We have a distance from the fisherman raft, and that's one of the covariates that we dropped due to the high correlation with the other covariates that we use.
What? Okay, so what about another covariate of level of cover, habitat cover, or canopy cover? Was that one of the? Was that kind of built into your maps there, habitat maps?
Yep. So canopy cover can be used for two types of data. One is the categorical, which we use in here as a habitat type. And then second is the quantified way using the spectral indices, which we originally have 4 spectral indices, which is NDVI, and then forget the second one. And something, there's too much, and spectral indices, but those 2 are dropped because they have a correlation to the MVI and MNWI and the other covariates.
Okay, that's what I was wondering. Thank you.
Thank you. Yes.
Why would local people want to conserve this species, and what can be done to, if they're already working on trying to conserve these species, what can be done to continue their partnership in this type of work?
Yeah, very good question. Thank you. So, local people. So, to be very specific, local people can like common people like me that live there use the national park, or the local people that means the entity of the companies, and the local people of the national park. So, I'm gonna answer the common people. Usually the fishers, and they use the Berbak National Park to fish for their source of income, because they're the only places that fish still live, still abundance. So yeah, in terms of partnership with the national park, they have the program of the community-based patrol, and then also they use for labor for the hidden programs. So it's a two-way benefits, and then they also provide the zoning of the national park, which the traditional fisher are allowed to catch fish on the traditional zone, but there's some restriction, like they don't allow to use the sophisticated to catch a lot of fish in one event. So they use the traditional way. So it's a best practice management for the area, and so integrating the social economical aspects. In terms of the entity of the plantation companies, they usually have a partnership with the national park. They provide funding for the program, also sometimes expertise and also equipment, also data sharing. So, but I can't say what's the effects, but it's a good thing. And then the company usually also have a CSR, corporate social responsibility to the villages around impacted area of the companies. So yeah, there's a lot of complex relationships going on. Some good, some can be seen very technical details, and then we can see there's a really important steps that we generally the compliance supports that good relationship and the rest. It's sometimes normally always happening. Yes, that's it.
Yeah. You have another question on the chat?
Matt. So Matt is the members of the IUCN Crocodile Specialist Group and is also the Pangolin Specialist Group.
Cool.
So it's a big deal.
Hey,
Nice
Dan.
to meet you.
Nice to meet you. Thanks for making this available over Zoom. It was a really great presentation and a super cool project. I'm super jealous you get to spend time with all those Tomistoma, Danu, and especially all those big boys. I would be curious, Tomistoma has a very similar ecology to Mecastops, which is the slender-snouted crocodile in West and Central Africa that I work a lot with. And one of the things that we are increasingly interested in is like space partitioning between individuals. And I know that you only collected, movement data from 5 males, but just informally, maybe as you were working in the habitat and doing surveys and looking for those animals, did you notice if there seemed to be any potential trends of those males excluding other big animals from their home ranges, or did you notice a lot of other smaller individuals within the same areas, or are they really kind of solitary and evenly dispersed throughout the habitat?
Thank you. That's a great question. Kind of beautiful. But our data can explain anything, any relationship between that. That's why we're suggesting on the population monitoring, so we can see not only the density trends but also the demographics of the individual Tomistoma, if there's any interspecific competition between the different ontogeny phase. That's why we suggest this, and that's one of the opportunity in this Berbak-Sembilang National Park, because they open for the collaboration. They were partnering with the ZSL before, but it ended after COVID, and even though it's continuous, the partnership itself focusing on this mountain tiger rather than the aquatic. So there's opportunities there. And what else? Oh, and also Berbak-Sembilang National Park has the annual crocodile monitoring program, but it's only once well, so I think there's opportunity to have a more robust surveys. There's a great insights and suggestion. Thank you.
All right, let's see what you come up with. Thanks, Daniel.
4 more minutes. Any more questions for Danu?
Yes, and I will end there.
What's the fire regime? Because there's one area that seems, there's one area that didn't. So is that normal, or is that?
Can you define fire regime?
Oh,
Sorry.
I guess
How frequent are they happening more often?
and like what's the natural
Density.
Yeah. Great question. So, 60% of the Berbak-Sembilang National Park is big swamp forest. Fire is not in the system, so it's usually wet. It's like a pit dome. Pit dome is like a accumulation of the thousands of years carbon. So it's usually located in the river basin. So it's like a sponges that will absorb water. So in natural condition, the pit will be wet. So it's a fire resistant ecosystem. But the fire, historically, it happens because of the humans incentive from fishermen and company, and then the El Nino usually make it worse. Sensitive. Well, the companies using in maps have usually their method to plant the oil palm is to drive all the trees from cattle and then circulate the water away from the liquid. So it's become very dry, and it's all like 5 metric tons of fuels. So it's very sensitive to, once it gets fired, it will be burned off. So from in our study area, we had the 1997 fires, and also the 2015 fires and 2019 fires. So on the extreme dry season, it's something that here. And I'm not really sure. I don't remember the cost of them, but one of them are due to the
Yeah, it's a great presentation.
Thank you, man.
I'm so happy for you, like seeing you there. I'm very happy. And you can see like you so close to your final degree, master degree in your hand. So my question is, since there is some sort of difference between the distance travel and the speed of the bird, do you think the age of those gharials natural here, like in play? Yeah, the age of those gharials or crocodile.
Yeah.
Yeah. So did you have the data of the age of those 5 different gharials?
Age?
Age.
Oh, age,
Yeah.
age. Yeah. So yeah, from the 5 crocodiles, we caught the smallest one is 3.9, and then the biggest one is 4.7. It's kind of hard to guess what age, but for just for the speculation or estimation, the Sunda gharials, the Tomistoma become mature, like reproductively viable, when they reach a size of 3 meters. So usually it's based on the captive observation. It usually takes 20 years to reach that focal length. And then after 3 meters, usually crocodiles will grows. The growth rate will be getting lower. So they may be grandpa. I don't know.
Probably because it's 3:45.
All right.
Sorry, but you guys
No
have
problem.
to
That's really no problem.
wait. Thank you.